Hello, everyone. I'm Noah, and this week I wanted to learn more about image classification with neural networks. So, for inspiration for this project, I decided to revisit the subject of my first capstone, which is a game that has been a part of my life since a young age. Magic the Gathering is a trading card game developed by mathematician Richard Garfield and released by Wizards of the Coast in 1993. And in the mid 90s, I personally was a bit too young to understand the mechanics of the game. However, a family member, about 10 years my senior, collected and played, and I have fond memories of looking through his cards and admiring their fantastical artworks. Magic is a game of color. It has 5 colors that are core to the way the game is designed and the way the game works. Color is often a player's first consideration when building a deck. A card's color can tell you what you need to play it, but most importantly today, color can influence the art created for the card. So, can we train a neural network to predict the color of a card based only on its artwork? Here I've chosen a few examples for us to look at, and you'll see that there is a lot of very colorful art on this page. But what I want you to notice, if we look at the top left card here, we have a card that has a distinctly white border that tells us that this is a white card. To the right, we have a blue card. Below, we have a red card. And to the right of that, we have this brown border that tells us that this is a colorless card. And by the end of the project, we will be ignoring those colorless cards today. So the game is designed with balance in mind. And thanks to that, our raw data is naturally balanced when we start, as you can see with the distribution of colors across our data set. And what we're going to do with this data is feed it into a neural network. And the way that that works is we take a look at a photo like this of this hummingbird here, and we feed it in pixel by pixel as inputs to our neural network. We have hidden layers here, and they will, over the course of examining this image, eventually learn to recognize features such as the wings of a bird or the color of its feathers. And at the end, we compress those features down to predict what that image is of. In the case of my project today, rather than 3 animals, we will be trying to predict 1 of 5 colors. And in addition to looking at each pixel, we're also going to examine the colors of the image by breaking them down into their 3 primary color channels, as you can see here. So our first baseline model performed a little bit better than expected. Random guessing would have shown us about 17%, and we started out with 38% accuracy. And if you look on the right at what's called a confusion matrix, what we want to see is a bright diagonal here that shows correctly predicted labels. And we have a few problems. Obviously, this model is very good at predicting red cards, but it's mispredicting colorless cards, which we will eventually remove, and predicting many cards as white and black incorrectly. So the next step was to apply transfer learning, which is the real power of neural networks, where we take a pre-trained model and leverage it against the task that we would like to perform. So I've chosen a model called Exception, which is pre-trained on hundreds of millions of images, and we're going to apply that model to our 19,000 card images to see if we can get a better result. Our first attempt at transfer learning showed a very minimal increase in accuracy. However, it did get very good at classifying those colorless cards, but the rest of the model seemed to suffer a bit. So we're going to make another change. Up next, we're going to drop those colorless cards and just look at our 5 colors like we talked about at the beginning. And immediately we're seeing a much better looking confusion matrix here and an increase to about 44% accuracy. Much better than we were doing before, but still not great. I'd also like to take a moment to point out that I did attempt this same model against grayscale images to very lackluster results. So finally, I took that good performing model and trained it for about 2.5 times as long as our initial model, which really did not do a whole lot for our accuracy here. So at the end of the day, what this tells us is that this is a pretty difficult problem. We started out with a baseline accuracy of 38%, and transfer learning only brought us up to 44%. And in my opinion, the art that we are looking at is very subjective. There are many different artists who are creating this art. And while the colors do tend to follow themes throughout the game, an artist decides which themes to apply and to what extent they're applied. So I have a simple visual aid here to kind of illustrate what I think the primary issue with this is. We have 2 pieces of artwork here that have a lot of red There's a lot of fire going on. These look a lot like red cards, but they happen to actually be blue. And while the model is actually very good at not mispredicting blue cards as red, I think that these are two great examples of that misprediction happening. And finally, how could we improve this model? Maybe longer training times. However, our last model showed that that might not be the case. More time spent fine-tuning could help us quite a bit. And we do have about 9,000 more images that we could try to train on, but I left those out for various reasons. Another option might be to look at different targets, such as card type or set. And here we have a stack of the technologies I used to complete this project. Thank you for your time. I'd be happy to listen to any questions.